So in order to understand the relationship between this growth hormone IGF-1 and how this change in all these levels can impact glucose in your body, let's take an example or analogy of the city tom-tom. Again, this is a very hypothetical situation, and there are some limitation in this the way of explaining things, but probably it's the better way or most logical or simplest way of explaining this relationship. So let's take an example of the city tom-tom. You can see the boundaries. Basically, this is city, and then there are really great people living in this city. As you can see, that these are the people living in the city. And in order to make sure that all the systems in the city they function properly and in a nice manner or timely manner, and all the smart people, what they do, they make plans, and then they execute all those things. So in order to make sure that all the system in the city or all the departments in the city basically work properly, what these guys did, they made a planning committee. So this is a committee basically, or you can say office, or you can say a team, or whatever you want to say. This is the planning. So this is basically is responsible for making a sensing change and then planning accordingly based on the different sensing mechanisms. We'll see in a second what does that mean in the next few slides. So now this planning committee basically just plans. So it basically sends something, and then they plan, and then what they do, they tell an executive committee, hey, look, yeah, this basically sends a feedback or a message to the executive committee. An executive committee is the one which has power to change certain things, right? It will do something, it will give a command, or so that the change can be brought out in multiple systems in the city, basically. So in this one, we're going to talk about a system which is called food supply system. I mean, of course, there are multiple other systems that these committees could be involved, but we're going to be talking about the food supply system in this one. So this is what the normal system is, and then what happens basically. So with executive committee based in consultants with planning committee. It basically, in order to make sure that the food supply system is functional, what it does basically, it has an in-house production house, and then what it does basically, when this in-house production house gets a message from the executive committee, it basically makes some food, or you can get a bread. Let's say this is a bread or pasta, whatever you want to say. This is the food made in the body, or so this is in-house production. But in addition to that, they also get some external supplies so that they could be variety, so that people can come and buy multiple things. So now, in addition to that, in addition to making, let's say this is a bakery, they made whatever bread, pasta, whatever, and in addition to that, what this bakery is going to do, or this production house is going to do, it's going to send some flyers to the city. Hey, look, we got a great variety of breads. These are very delicious. Come and buy it, right? So in response to that, these guys are going to come and buy it. But they have a rule here that make sure that at any given time there are at least these many breads or the goods present in the store all the time, so that we never run out of that. So this is how they plan. So this is a perfect system. Let's say they know how much they need, and then the planning committee basically correctly estimate what is needed, and it tells the executive committee that this is what we needs are, and it basically prepare or make in-house production or get it from outside to make sure that all the demands are met, but also there's a minimum requirement which is always there. So let's say if that's the case, so what will happen? Let's say everybody took this, they got the message, and everybody took this food, and now you see that everything is empty again, and now this is a situation, everybody is fed, everything is well controlled, but also see that the minimum requirements for the food in the store is still met. So now so this is what happens in normal situation, like daily situation. Every day this is what they're doing. So what happens next is let's assume there's a game in the city, let's say football game or whatever game, and of course when there's a game there will be a lot more people in the city. So what this planning committee, this basically thinks and ponder, oh my God, now we have to think about it, we have to plan ahead. So what this planning committee does basically, it tells the executive committee, you see that the thickness, please pay attention to the thickness of these arrows because this would indicate increase or decrease as we move along with the presentation. So this planning committee tells this executive committee, oh, we're expecting more people, so you better make more food or make more food available. So what it does basically, it tells the production house to prepare more food. You see that there's more food available now on the shelves. And then in addition to that, this also tells it sends more flyers so that everybody knows this. Like in addition to the normal circulation, maybe they will send it to the place where the games are happening or whatever. So so in addition to increasing the production, they also basically increase the pamphlet or flyer information. And what happens next is basically you see that although they made more than what is needed or what was needed regularly, since there were a lot more people, they could get more food, and basically still the concentration is maintained. You might see that there are some people who did not get food. Well, basically the people either they came to the store, they didn't find any food, or they just didn't like the food there, or whatever. So basically, overall, what the meaning of showing this way is that there is more of demand than supply. So demand is still high, and supply is all kind of optimal because they want to maintain this food number ratio. Okay, so now if you have understood this, here is your Tum Tum City. This is what we're talking about, food supply system. And this is your planning committee, this is executive committee, this is house production. And this is where the food is there. And these are basically the consumers or regulators of the food. Okay? So now let's change one by one the name of these things. So let's say instead of Tum Tum City, now we're talking about your human body. So so when we were talking about food supply system, we were talking about the blood glucose levels. When we're talking about planning committee, we're saying it's hypothalamus. When we're saying that executive committee, it's pituitary. And we say house production, what is that? It's liver. Let's say example, liver. And then what is this? This is food, right? So what is depicting? In city, this was food, right? So what is this in your body? So basically, this is the glucose concentration. You see that? This is how the normal blood glucose level looks like, and this is like more than what is needed. And then these guys are going to come and then take it. And what are these guys then? So this is example of anything that can take glucose from the blood glucose level, from the blood, so that it can decrease blood glucose level. For example, these could be the skeletal muscles, right? So they can take the blood glucose and they use that in energy, right? So let's see an example of how this glucose is regulated by the both growth hormone and IGF. So based on that, and if you understood this, where is the growth hormone? Right here. So growth hormone is right here. This signal is from the pituitary to liver is basically growth hormone, right? Because it's telling that you have to synthesize the IGF. What is IGF? IGF is this guy. It is telling that you need to get the blood glucose. You need to take the blood from the. You need to take the glucose from the blood, right? And what is this basically? So in order to maintain normal glucose levels in your body, liver also does multiple things. One of the things is gluconeogenesis, glycogenolysis. Gluconeogenesis is basically production of novel glucose molecule. So whenever you're fasting, basically you don't have, let's say, energy or your glucose in your body. The growth hormone basically initiate the process of glycogenolysis or gluconeogenesis, so that you have glucose in your body. So you can sustain. And in addition to that, it also has IGF function, which is probably more pronounced during the growth period, basically. So it also tells the muscles to take up glucose from the blood, basically. So they are working just like a team. Although it appears that this is increasing glucose in the blood, but this is decreasing glucose in the blood. But they are working in a team basically to make sure that everything is maintained at a proper level. Um, and of course, this is one aspect we're looking at. We're looking at just glucose only right now. In fact, that we explained that we discussed in the class that growth hormone and IGF they have multiple effects. And adipose tissue, skeletal muscle, liver. For example, in skeletal muscle, they have exactly opposite, right? They reduce glucose uptake. Growth hormone reduce glucose uptake, whereas IGF actually increase glucose uptake, right? And liver, it basically increases gluconeogenesis, glucose production, but here it basically it decreases glucose production. It basically causes lipolysis. That's another reduced body fat mass, basically. In addition to that, I mean, we're not going to go. Don't bother. I mean, don't worry about all these signaling pathways. All these mechanisms. The purpose for me is showing this is that, and this is taken from this journal, Nature Clinical Practice. In case if you really want to refer, there are complex mechanisms they can interregulate their own, not only on their own but also others. Like for example, here growth hormone is checking regulations of insulin signaling, basically. So, how do you basically envision I mean, this is so complex. So, how do you understand how does the growth hormone and IGF they work in a team to regulate normal body function? Let's take an example. So this is an example of low growth. This is normal growth. This is abnormal growth, and this is a situation of the person who they are all the same age, because that's critical to say that this is normal or low or abnormal. They all three are the same age, but here you see that this is low growth. This is normal growth. This is abnormal growth. The first thing you notice basically is you see that this guy is shorter in height compared to all these guys, and this is higher than this. So this is normal, this is shorter, this is abnormal. So what the first thing you can get impression of, that growth hormone here is the lowest. This is optimal. This is more growth hormone. Makes sense. This is very simple, just looking at that. And the growth hormone also does what? It also causes growth, right? So you see that there's more growth hormone, you see more growth. So you see that the skeletal muscles, the body is increased. Other thing which the growth hormone does is that it basically breaks down the fat. So you see that here, there's more body fat compared to this guy. This guy is thinner. So relationship between growth hormone and the body composition and body size can be depicted by this. But how does this change the glucose function? So let's then take an example of growth hormone excess when there's too much of growth hormone. Okay. So the same system that we saw earlier, here's your hypothalamus, pituitary, and this is your liver, and this is your blood glucose level, and this is basically where the blood glucose can go, like left, for example, skeletal muscle. So this is a situation when everything is fine, except there's tiny bit more than what is needed. So see that everybody got whatever they were supposed to get, but there's something more than what is optimal, so this is like higher. So at this situation, although it is a little higher, it's a very mild growth hormone excess. So it's this excess, which is very mild. And whenever there's more in glucose in your body, in a normal situation, what happens? I mean, there's another player, which is a major player, or the biggest player in glucose regulation is insulin. So what happens is there's more glucose in your body, insulin gets in, and then it basically helps to get the glucose in the skeletal muscle or wherever it is needed. So you see that when there's a little bit higher glucose because of growth hormone excess, you probably might not able to detect it if this is mild condition. Why? Because there are other compensatory mechanisms that can again normalize the blood glucose level. But there could be a situation when there's more of the growth, there's too much of growth hormone here, and there's too much of the blood glucose concentration here. Because remember, I told you that growth hormone can eventually cause hyperglycemia and hyperinsulinemia. So now see that there's too much of glucose in the body. So now, not only too much of glucose in the body, you see that the supply is more than demand. You see that there's now more of glucose in the body. This is a case of, let's say, moderate growth hormone excess. Okay? Let's take another example when there's actually too much, but both glucose from the internal sources and external sources that you take from food. So what will happen eventually? here, still there's too much supply than demand. Now this is an excess that the body cannot regulate. And then here's the situation of hyperglycemia, and since there's too much of glucose all the time over the period of time, the person is going to develop insulin resistance, and eventually all the metabolic complications. So you see that how a growth hormone excess can actually cause hyperglycemia and hyperinsulinemia and insulin resistance and metabolic disorder eventually. So this is an example of growth hormone excess. Well, I just explained to you. What I'm telling you actually, these are from the actual data published in papers. See that you can go through all these papers I have just for you guys. It's telling exactly the same thing as we just saw, right? You can go through this link basically. It might provide you full text in case you want to really go more detail down the road. So let's take an example when there's less of growth hormone, right? So the growth hormone when the case was there when there's growth hormone deficiency. So again, let's take an example of normal situation when there's normal production. Everything is so the supply is still kind of all equal to the demand. So this, for example, here is the normal situation. You see that this is production. This is taken by external sources, and then you see that the supply is equal to demand, and then eventually this glucose is going to be taken up by the skeletal muscle, and you will have a normal situation, right? So let's take an example when there's a growth hormone deficiency. We're talking about a mild deficiency. So see that the thickness of the barrier or the arrow here, it's low. It means it's a deficiency in growth hormone. So you see that that's of growth hormone, less growth hormone. And because of less growth hormone, it is going to tell liver to synthesize less of glucose too, right? And then the IGF level is also going to go low. So means not only it has reduced production, but also basically the flyers which were sent for glucose uptake, the IGFs, they are low too. So now what will happen? Let's see. Here you have to make sure you pay attention to that. This is although the production inside is decreased too. Let's take an example when the external intake is low too. For example, a case of babies. Like babies they largely depend on food from mother, right? So external source of food is not like a primary choice there. So in this case, the measure is internal source compared to external source. So in this situation, what can happen? Since there is more of demand than supply, actually this can cause hypoglycemia, right? So in acute situation, when most likely this is the case in the babies, growth hormone deficiency can lead to hypoglycemia, and this is the case in babies. But let's take an example of adults, or as we grow. We also take glucose or other carbohydrates from external sources, right? So in that case, what can happen? Even though the production is low, you have external sources, glucose or carbohydrate levels high because of external sources. What can happen? You see that here, still, so whatever. Let's go back to this guy right here. So you see that this is low production because of low growth hormone there. But since there's more of glucose from external sources, it is still more than what is required there. Why? Because the low level of IGF, it changes how your blood glucose homeostasis really works. It basically causes dysfunctioning in the blood glucose homeostasis. So now you see that now those are taken up, but still, there is more left here than what is needed, right? And this is a case of, let's say, mild growth hormone deficiency, when still you have a little bit more than what is considered optimal. But let's take an example of a situation is when you have excess of growth hormone deficiency. There's nothing is coming here. You see that it's completely growth hormone deficient. So what you're taking basically is your IGF is not there at all to tell that to take the glucose from the blood, basically, and eventually it also messes up basically the beta cell function down the road in the pancreas, so you have less of insulin effect. So eventually, there could be a lot of blood. There would be a lot of blood. There would be a lot of glucose in your blood, and it is exceeding whatever is the capacity or whatever you call optimal blood glucose concentration. And this is a situation when you have hyperglycemia, when you have too much of glucose in the body. So you see that depending on what phase of the life you look at, whether it is a baby versus adult, where the growing where baby versus adult, basically, you might see different effects, right? And also how long the situation has been in place. Like, for example, somebody who just got neonatal, if somebody is, let's say, a neonatal baby just diagnosed with growth hormone deficiency, do you think that you will see any effect? Probably not, because the neonatal growth is not dependent on growth hormone, right? So you see that, and as as you increase as you basically grow with the age, if you have less of the growth hormone, it will manifest as like mild obesity, and then impaired blood glucose levels, and then stunted growth, and all those things. So you see that. Again, whatever I just told you, it is basically, again, from studies and papers. This is taken from this Pituitary Society website. It's a full PDF if you want to go and read the entire one. But it's telling you the same thing. You see that? The consequences of growth hormone deficiency vary depending on age where it occurs. Babies lacking growth hormone may develop hypoglycemia, while children and adolescents with the growth hormone deficiency grow more slowly than normal, and if left untreated, become unusually short adult. And they also have more body fat, especially around the waistline, and may not achieve normal bone. So that's basically what happens. It may be what happens when they're growing in adolescent. An adult, if this growth hormone deficiency is continued and it's untreated, basically, you can see all those things, and you see that it can also increase higher cholesterol level, insulin resistance, which can further increase the chances of developing diabetes mellitus. So you see that it depends how long the disease is there, and also what stage of the life you're looking at it. And again, it is backed up by the studies. You can see this is mostly very recent study. So this study is basically from this published journal, which is kind of relatively recent. Which is telling the same story that the adults with lifetime untreated growth hormone deficiency, they have impaired insulin sensitivity and beta cell functions. You can read on in detail if you want, but this is just an evidence based on whatever we're saying, that those are evidence based on the studies in the real world. So these growth hormone deficient patients, they have reduced beta function, higher glucose tolerance, or hyperglycemia. Although the studies found no insulin resistance, but there are studies which say that the insulin resistance is also there in people with impaired growth hormone deficiency. You can go and read all these papers basically if you want, but the bottom line is that I give you already the crux of whatever the entire story is. And of course, we are learning more. We don't know everything. There's just so many things. For example, this paper, which is very, very recent one, it basically is telling you that yes, we know a little bit about all these things, but we don't know the entire picture. We're still figuring it out. So there are more studies which are needed to really understand the relationship, or precise nature of this relationship. Okay, so that's basically that's it basically. And again, just to quickly summarize what you have to understand and remember. I mean that's whatever I just told you. It's a really, really complicated information. It's too much information. But what is the meaning of? What is the crux? What do you have to remember and memorize? So all you have to memorize is, in a normal situation, the growth hormone and IGF, they are working in a team basically. They have complementary function. It might appear that one is increasing glucose, another is decreasing glucose in the blood, but actually that's complementary function, as I just explained to you in the video earlier. So Whenever there is normal situation, which is this guy, you see that this is normal growth. There is still high growth hormone compared to this guy, but this is backed up by, or this is supported by IGF function as well. So now they're working in a team to make sure that everything is optimal. But in case if anything goes low or high, it's going to change multiple things. And one of the things is glucose. And then all, if you can remember and understand, is that eventually the blood glucose levels or blood glucose system is going to be impaired. Either way, if it goes low or high, right? We're just talking about the blood glucose level right now. Of course, you can detect when there's growth hormone excess or deficiency, just looking at IGF level or growth hormone, or looking at visually looking at it. So basically, you can see this is basically growth hormone deficiency. This is excess of growth hormone. You see that? If you remember that and understand that, I think so. That's much more. It's probably okay. You don't have to go through entire detail how those things happen. All you have to memorize is that in normal situation, growth hormone and IGF, they work together. Although the function or the effect you might see appear to be different, opposite, but they are complementary to each other, and eventually they are maintaining homeostasis. As soon as things are disturbed, whether the growth hormone goes low or high, things change and it will mess up the blood glucose levels or system. Okay, that's all for this. Also, somebody asked in the PBL today this question about how the GnRH agonist could be used for the controlled ovarian stimulation. I think so. I explained in the lecture too. I would highly recommend going back to the lecture and especially looking at the video that explained how this follicle stimulating hormone and luteinizing hormone, they basically are involved in producing effects in ovary and then overall the menstrual cycle and pregnancy. There's a video there in that chapter. I would highly recommend you go and just look at that video. But just quickly that whenever there's two of these hormones from pituitary gland, FSH and LH. So FSH is basically stimulating the follicle, and LH basically releases the egg so that it can go and further get fertilized, right? So all you have to memorize to understand this is that LH is causing the egg to be released, right? But let's take an example of that's called IVF, right? In vitro fertilization. For that, you need a lot of eggs so that you can take the eggs and then you can fertilize those eggs externally. For that, you need. For that, you don't need egg to be released. You need so many eggs in the ovary so that you can collect those and use externally to artificially inseminate that, right? So, but the biggest problem in stimulating that way is that as soon as body sense that at this particular step, there's a lot of luteinizing hormone. It basically triggers the egg from the ovary. So you want to stop this so that the egg can stay here and you can retrieve those eggs for the further IVF technologies, right? See that reproductive technology, assisted reproductive technologies. So the way it is done is one of the ways of doing is that you can give the GnRH agonist chronic treatment. Remember, the chronic treatment of GnRH agonist is going to do what? It's going to stop or shut down the axis. Remember, initial phase is going to be increased, but then eventually it's going to shut down. It's there in the notes. You can go back and read that. So approaching that, there are multiple ways of doing this. You see that this is an older version, or still probably still used, but this is just probably the relatively older version than this guy. So in which we are using agonist, GnRH agonist. So what happens basically, you treat with the GnRH agonist. What the GnRH agonist is going to do, they're going to desensitize so that the external, the internal, which is the top pituitary control, is abolished now. So all you're doing is externally stimulating by FSH injections. The follicle stimulating hormone, you're stimulating the eggs in the ovary, and eventually you can collect with HCG injections. And then you can do the same thing. The purpose here is that you want to stop the LH surge so that it does not kick the egg from the ovary. So other way of doing it could be that the overall what is happening, you're decreasing the function here. You can decrease the function with antagonists too. You see that? You can, instead of treating this for a long period of time, you can just block the LH surge whenever it occurs, basically with an antagonist. So there are multiple ways of doing it and different protocols actually in different clinics. This is the paper which is probably I've taken this picture from. You can go and read it. It's a very reputed journal in Lancet. So this is how you use a GnRH agonist for IVF treatment for controlled ovarian stimulation. So I hope this helps. Uh, and I know it was a little confusing, the growth hormone IGF and glucose part, but if you go through this video, it'll help you understand that. If you go through in all the details and everything, that's wonderful. But if you think that's really too much information, all you have to understand is that in normal situation, growth hormone IGF, although they might appear to produce different effects, they work in a team, in a complementary manner basically, and then eventually everything is normal. Anytime it is disturbed, whether it goes down or up, there's different mechanisms they come into play, and then eventually they cause problems. It will mess up with the glucose metabolism. Okay. I hope that helps, and I wish you good luck.